I am Belated Tech. Welcome to Belated Tech Musings. Tesla makes exciting and well-engineered cars. Because of this, many think of Tesla as a car company. Others who need reliable backup power solutions consider Tesla as a power storage vendor. And yet another group who needs alternative energy generation point to Tesla as a solar equipment supplier. And Tesla is all three of these things. At the core of Tesla's business model, there is one sole product that underpins everything that the company designs, manufactures, services, and promotes. Without this product, Tesla electric vehicles, power panels, and solar arrays don't exist. Yet you can't buy this product. Tesla doesn't advertise it, they don't talk about it in their annual report, and CEO Elon Musk has never once mentioned it in his quarterly letters to shareholders. What is it? It is the Tesla lithium-ion battery. Let's take a look at what makes the Tesla battery special and see if we can't figure out how many of these batteries Tesla has actually made.
The 2170 battery is a variant of the 21700 commercial lithium-ion battery commonly used for a wide variety of commercial and industrial products, much like this Samsung example. What makes Tesla's battery unique is the specific chemical formulation in its 2170 battery versus the chemistry of common 21700 cells available on the open market, and the way Tesla engineers control the activity of the 2170 during use. 2170 refers to the battery's dimensions: a cylinder 21 millimeters in diameter by 70 millimeters in height. Tesla manufactures two kinds of the 2170 battery, one for its cars and one for its energy products. The 2170 for cars has an NCA chemistry, meaning a lithium-ion cathode, or positively charged zone, also containing nickel, cobalt, and aluminum. The 2170 for energy products has an NMC chemistry, nickel, manganese, and cobalt. Either 2170 variant has a graphite silicon anode, or negatively charged zone. Assembled and charged, the 2170 can generate 3.7 volts and 17 watt-hours of power. The 2170 battery took the place of the 18650 battery at Tesla, which is still used for Model S and Model X cars. Like the 2170, the 18650, manufactured at Tesla, is a variant of the 18650 commercial lithium-ion battery. Like the 2170 battery, 18650 refers to the battery's dimensions: a cylinder 18 millimeters in diameter by 65 millimeters in height. And like the 2170, Tesla manufactures two kinds of the 18650 battery, one for its cars and one for its energy products. The 18650 was manufactured in two different anode chemistries, either all graphite or graphite silicon, and two different cathode chemistries, the latter variant with less cobalt than the earlier variant. And in spite of its smaller size, its similar chemistry means that the 18650 also generates 3.7 volts, but its lower energy capacity means that it produces 12 watt-hours of power, about a third less than the 2170. It is no secret that Tesla has partnered with Panasonic to make its batteries, and relies to some extent on Panasonic's specific chemistry formulations and proprietary manufacturing equipment. In fact, Panasonic runs a portion of Tesla's Gigafactory 1 facility, where Tesla manufactures batteries and battery packs. Production bottlenecks have meant that Tesla has used a small quantity of batteries from Samsung, but it is Panasonic who is the main partner. Tesla has made the move to reduce its battery count in its products by acquiring ultracapacitor manufacturer and battery researcher Maxwell. Capacitors can be used in some areas of the car in lieu of batteries, where energy storage is less important than energy delivery, assuming that reliability and cost is similar or better. And of course, Tesla is constantly looking for better battery chemistries than Panasonic can deliver. Tesla also faces two significant constraints when manufacturing its batteries: raw materials and manufacturing efficiencies. We'll examine the raw materials issue in a future episode. In spite of the 3,000 employees at the Gigafactory 1, battery manufacturing is primarily an automated process. Thus, better manufacturing equipment is a key element in production throughput. To that end, Tesla has purchased Canadian battery equipment manufacturer Highbar Systems earlier this year. To some extent, this acquisition is related to the Gigafactory 3 facility being built in China to manufacture Model 3 sedans for the Chinese domestic market, as Highbar has a significant Chinese presence. But there is little doubt that Tesla is looking for improvements to Panasonic manufacturing processes, and Highbar is probably one piece to that puzzle. But for the foreseeable future, Tesla and Panasonic's fates are inextricably linked in the production of batteries for Tesla's current and future products. Tesla currently manufactures and sells 3 different car and 3 different power systems that consume 2170 and 18650 batteries. The Model X and Model S sedans use 18650 batteries, and Model 3 uses 2170 batteries. Since 2017, Powerwall, PowerPack, and Megapack energy storage systems use 2170 batteries. The Model Y, pickup, semi-truck, and updated Roadster are all expected to use 2170 batteries, but none of these models have yet gone into production. The number of batteries used by each vehicle varies even within a specific model. For example, the Model S is or has been sold with a 60, 70, 75, 85, 90, or 100 kilowatt-hour battery pack. Tesla does not release statistics on how many of each type is made within each model. Regarding energy storage, Tesla does not even release the number of Powerwall, PowerPack, and Megapack systems built and sold. Rather, it periodically reveals the gigawatt hours manufactured for energy systems. Even the exact number of vehicles built and sold is a fuzzy number in Tesla press releases, quarterly reports, shareholder letters, and annual reports. There are some inconsistencies in the announced figures, and independent estimates also vary at times significantly from official figures. When formulating the number of batteries used for both energy systems and vehicles, reasonable estimates were used to resolve inconsistencies and missing data. A Model S Type 85 uses 7,104 18650 batteries. That seems quite a lot compared to competitor vehicles, which use custom form factor prismatic or bag cell batteries. But using small cell batteries allows Tesla to standardize on only 4 battery types for all of their products. So Tesla gets the largest economy of scale among all the e-vehicle suppliers. The second major advantage of using many small cells instead of a few large ones is failure management. If one cell fails among 7,104 cells in a Model S, the battery management system isolates the failure and produces power with no noticeable effect on the performance of the vehicle. If one prismatic or bag cell fails in a competitor's product, there is significant performance degradation. Similarly, a Model X Type 90 uses 7,430 18650 batteries, and a Model 3 Type 75 uses 4,416 2170 batteries, and a PowerPack Type 100 uses 5,888 2170 batteries. Considering that Tesla has built and shipped more than 800,000 vehicles and 3 gigawatt hours of energy products, one can start to see that Tesla has produced not millions of batteries, not tens of millions, not hundreds of millions, but billions of batteries through 2019. The true scale of Tesla's operations is truly stupendous. Using Gigafactory as the name of a manufacturing facility is not just idle marketing, it is a fact. Through the third quarter of 2019, Tesla has built and shipped 2,450 Roadsters, 318,000 Model S's, 135,000 Model X's, and 355,000 Model 3s. As previously mentioned, Tesla has shipped over 3 gigawatt-hours of energy storage systems. After estimating the number for each type built for each product model, we computed the total number of batteries made. Tesla has used about 19 million batteries for Roadsters, 2.3 billion batteries for Model S's, 1.1 billion batteries for Model X's, and 1.3 billion batteries for Model 3s. About 190 million batteries were consumed in the production of energy storage systems. Some additional math reveals the total number of 2170 batteries made for cars to be 1.3 billion, and the total number of 18650 batteries made for cars to be 3.3 billion. Energy systems have consumed 29 million 18650 batteries and 159 million 2170 batteries. Thus, 3.4 billion 18650 batteries have been used overall, as well as 1.4 billion 2170 batteries. That's right. Tesla has built and used 4.8 billion lithium-ion batteries. But wait, Tesla has also made batteries to replace bad battery packs in cars and energy systems already delivered, as well as a certain amount of defective batteries have been produced and discarded and/or remanufactured. We estimate wastage, spares, and research and development demand to be an additional 10% of all batteries used in shipped products. So the final number is 5.3 billion batteries. Billion, as in B. That's a lot of batteries. How close is our number to reality? Panasonic has claimed that the Gigafactory 1 currently produces 24 gigawatt-hours of batteries in a year, out of a theoretical 35 gigawatt-hours possible with 100% efficiency. Our computation of current Gigafactory 1 productivity based on our estimates by product is 26 gigawatt-hours, including wastage, spares, and R&D demand, and 24 quality control gigawatt-hours for products alone. We're pretty happy with our figures.
I hope you enjoyed this episode on the Tesla 2170 and 18650 batteries. If so, click that like button. Let us know that you want more of these types of episodes by clicking the subscribe button. Activating the bell icon will also make sure that you receive notifications of new episodes. Links to material related to this video, the BTM channel, Tesla, and Panasonic can be found below. Save the link to our Instagram account so you can get early updates to our channel. The spreadsheet showing our computations in this episode can be downloaded for free from our Patreon channel by our patrons. Thanks for watching.